Hi, this is Kyle Houchins. I'm a tech and a trainer for McNeil, and today I wanted to talk to you about one of the more exciting features of version 8, which is Shrinkwrap. And I wanted to show you a workflow and how this tool can be used, and basically show the benefit if you're doing 3D printing, and also shelling, which I wanted to talk to you about, which is something that used to be very difficult to do in Rhino, and it's actually super easy now. So I've got this model, and you may recognize this back from the version 7 days. I've dusted it off from one of the rendering videos. And the reason I wanted to use this is because this model's kind of a mess. If I grab this thing and I run show open polysurface, it's going to show you that this thing is open, it's got surfaces, it's got stuff that's just mashed and overlapping. Showing you a little bit of how the sausage is made here from some of my rendering videos. But this thing is not trimmed. It's got a bunch of overlapping stuff, right, in two directions that I just mashed together for the rendering video because I never really intended to do anything with this other than just make a rendering video. But it actually turns out that this is a really good case study for shrink wrap. And if I decided at a later date, which I did, that I actually want to print this thing, it's a mess and it wouldn't print right now. And I don't like how this thing is set up to do that. So what we're going to do is we're going to grab the entire model, and I'm going to switch to shaded mode for this because it's a little easier to see. And we're going to run Shrinkwrap. Brings up a dialog box. The very first thing I'm going to do is I'm going to hit preview, and I'm going to let it run, and then I'm going to hide the input objects, and you can see what it's done is it's made kind of a pile here. I was going to say something else, but it's made kind of a pile, and this isn't super useful, but the one thing that you'll notice, it is combined everything together into one piece, right? And so what we can do now is start to refine this. And the first thing that I'm going to do is I'm going to actually not fill the holes, which seems a little bit counterintuitive, but I'm also going to crank this down all the way. I'm going to just take this to 0.01. This is a fairly small model, so it's something that, we can get away with that. So I'm going to go ahead and do that. And then I'm actually going to take the polygon optimization, which is a decimation. I'm going to take that down to 0 because I want the full tilt boogie. I want to see all of the polygons. And we're going to go ahead and say, okay. Now, the cool thing about this, it actually completes fairly easily. And if we run polygon count, you can see that there's 1.5 million triangles in this part. Now that's rolling a little deep, right? But it's not out of the realm of any possibility for what any modern 3D printer can handle. We could always run mesh reduce on this. We could always do a bunch of things in order to get that to work. Now, if we go to rendered mode, you can take a look at this, and you see that's actually done a really nice job, right? But the coolest thing about this is a closed mesh, right? So this, right now, this chunk is ready to print. Now, a lot of you may know I spent most of my career in the toy industry, and one of the things that we used to have to do all the time with digital models is actually to core them out in order to be able to put mechanisms or batteries or speakers or whatever, right, inside. And that was always just an absolute nightmare. In fact, there was tons of workarounds and tricks and all sorts of stuff that we had to do. None of them were good. And so what we can do now, and especially in Rhino, I'm going to hide this light. Especially in Rhino, this was really, really difficult to do because it essentially meant that you had to go through and individually offset each part and then individually Boolean the thing and actually make a second model inside a model. Well, in this case, and I'm going to hide this guy for now. In this case, what we can do is just shrink wrap the shrink wrap. And I'm going to shrink wrap this, but I'm going to use the offset. And I'm going to actually offset this negative 0.08, which is about what I would like to do, right? I'm going to preview this. It's going to go fairly quick. I'm going to hide the input object, and you can see that we end up right back where we were before, right? So this is a highly optimized mesh, and if I crank this down to 0, you can see that it starts getting a little better. I can start cranking down or cranking up the detail by making the edge length shorter, and then you can see that I get a really, really good result of this thing as it sits. Now, there's a smoothing tool in here as well, and so what I can do is I can crank this up a little bit and lose a little bit of detail on the inside, which is fine. That actually is not a bad thing as far as what I want to accomplish. So I'm going to go up to like 2 or 3, and I may actually add a little bit of polygon optimization in here just because I don't need quite that much detail. I'm going to leave the fill holes off again, and it's going to redo this and let it run. And so what you can see is I end up with this offset of my offset. Now, the last part of this party trick that Shrinkwrap has is if I go in here to the standard toolbar and I grab a mesh box, actually I'll just do this from up here. Grab a mesh primitive, and I'm just going to do a box. I'm going to do it from 0, drag it out here, go to the front view, make it taller. I'm going to make sure that it intersects like that. The other thing that's cool is that mesh booleans have been rewritten for Rhino 8, and they actually work now. Hooray! I'm going to come in here and I'm going to grab a mesh split, and I'm going to grab this, the outside. I want to make sure that I'm grabbing the outside. I'm going to split this guy in half. And I think you can probably see where I'm going here, but wait for that to finish. I'm going to delete my box, and I've got 2 halves. Now I'm going to hide 1 half. You can see that the offset, I can check it, make sure that everything looks lovely here. I'm going to go and I'm going to do a mesh boolean difference. I'm going to remove the inside from this. I'm not going to delete the input because I need to use it for the other half. It's going to think for a second. I'm going to hide this so you can see it, and voila, we have a really nice shelled part. And because we ran a little bit of smoothing on the inside, you can see that we actually lost a little detail inside, which is what we wanted. We wanted the inside to be a little softer. This is what old people like me refer to as a wax offset. They used to do offsets in real parts. They would machine the cavity of the tool, and then the core they would actually lay machinist wax of a certain thickness inside, and then they would pantograph that in order to get the other half of the mold, or the inside of the mold. It makes a really nice, what I like to refer to as a wax offset, which is nice and soft and easy to work with. Let's finish this up. So if I grab, let's just hide this side. I'm going to do the same thing again. I'm going to just do a mesh boolean, not a regular boolean. I'm going to do a mesh boolean, and I'm going to do a difference. Pick this, pick that. I am going to delete the input this time. Wait for that to finish. Bring the parts back, and I can pull this apart. And let's take a peek. Beautiful shelled parts, and white feels a little bit like cheating, so let's add a material to this, and then that way we can kind of see really what's going on here. Right? Nice detail. Now, because this is a voxel process, right, you're going to lose a teeny tiny little bit of detail in the corners because voxels don't make perfectly sharp corners. But what I find is the detail loss, depending on the settings that you use in Shrinkwrap, can be under the tolerance of your printer, or by the time you get the thing out of the printer and clean up the part, even if you wash it in some ISP or whatever you're going to do, like you're sanding supports off or washing an SLA part, or however it is that you're going to post-process this thing, whatever you lose is completely and utterly inconsequential. The thing that's important is if I grab this thing and I run check, it's going to take a peek at these meshes. These are good meshes. So It's got two pair of faces that intersect each other. That's zero issue. This is the thing that's important. Doesn't have any degenerate faces, no n-gons, no manifold, no naked, no duplicate. Doesn't have meshes that different, that have normal issues. It doesn't have any disjoint pieces and doesn't have any unused vertices. And so this is a valid mesh. And so this can go, same thing with the other one, it's the same, pretty much the same report. So this can go to a printer all day long and go from there. All right, so you can take this part, export STL, grab this thing and say file, export selected. We're going to set this as an STL. There you are. And we're just going to call it ray gun. This is the left side, ray gun left, throw it on my desktop, and we're going to hit save. We're going to use binary because it's a much smaller file, and we are not going to export open objects. So if there is a problem, as long as this isn't checked, it's going to the export will fail. But because it went out successfully as an STL, this is good. I do the same thing for the other side, and I'd import each part into the printer and then run them, separately so that I can move them around. Sometimes if you send out an STL with two pieces in it, you can't separate those two pieces, or you can't, transform them separately within the printer software. So I always send out individual STL files for each part that's in the model. That way I can edit them and move them around and nest them and things like that in the printer. So that's what I want to show for shrink wrap and getting a shelled part with a polygon result. The next thing I want to show you is what happens if you want a NURBS result. Now I can hear what you're saying. You're saying, Kyle, but polygons are for nerds. What I want to do is have my model be in NURBS. Well, okay, so let's take a look at this. I Booleaned this entire object together, and I split it in half and I capped it. And this is where the story used to become really, really complicated before version 8 and Shrinkwrap came out, right? In order to be able to shell this, you had to basically recreate all of these surfaces offset to the inside and then try and figure out how to intersect them and all that kind of stuff. And it actually ended up being something that was a line item when I had my consultancy. If you needed a shelled part, it was like an additional day or two worth of studio time in order to be able to get that done. Now, in this case, what we can do, let's bring the entire thing back together, and I'm going to just shrink wrap both halves here because it doesn't matter how we do this, and as far as whether the parts are separated or anything like that, because it wishes it all together for us already, which is fine. And we're going to do the same thing we did before. We're going to just drop the polygon count. I'm not going to fill holes on this. That leaves this open. And I'm going to let the optimization be, kind of high because I don't need crazy amounts of detail for the inside of this thing. I am going to offset it just like we did before, 0.08. That's going to give us our offset. I am going to smooth this just a little bit to clean up some of these little frags that are hanging out in here. And it looks like a value of 3 kind of gets us there, right? And so what I'm going to do now is I'm going to just go ahead and accept this. I'm going to isolate it so we can see what it is. And take a look. And you're like, great, that got us right back to where we were before. Like, why do I care about this? Well, the cool thing that we added in V7 was quad remesh. And quad remesh allows us to take an unorganized triangle mesh and re-topologize it with quads. And you're like, great, why do I care about that? Well, that's because from quads, you can convert to sub D. From sub D, you can convert to NURBS, which means that you can end up with a NURBS result of this core. Now, the cool thing about this is, let's just go ahead and accept it as this. Maybe we go just a little bit higher. Maybe we go like, let's go like 3,500. Just get a few more details in here. Depending on how much detail you need, you can adjust the target quad count up or down to get a, decent result. All right, so let's go ahead and keep that. And I'm going to invert the selection. I'm going to just delete the mesh because I don't need it anymore. And then I'm going to just use the to subd command. And I'm just going to use all of this stuff as default. And I'm actually going to just delete the input because I don't need it anymore. And you can see that we end up with a closed subd part. Now, this is particularly cool because in areas like this, where this is kind of stinky down here, we can just deal with that. You know, we can just like any other subd part, we could delete this stuff, and then we can, you know, we can bridge over these things and, you know, fill all that up. I'm not going to go through all that because there's plenty of videos showing how to do that. But what we can do now, you know, but the point I'm trying to make is that you can actually go in and clean this stuff up. So if you see stuff that you don't like maybe you don't like this, or maybe you didn't, you know, this little trigger nubbin in here isn't to your liking, you can go deal with all of that stuff because it's just a subd, and all of the subd stuff that you know works. You know, if you've got too much detail, you can just, you know, double click, get an edge, and you can delete the edge. And you can selectively remove detail throughout the model, whatever you want to do, right? So let's follow this through, and let's go to NURBS. And we're going to delete the inputs, yes, and then the subd options, we are going to go ahead and pack it. And you know, G1 is fine. We don't need to get crazy with any of that, so we're just going to leave that set to the defaults with the exception of deleting the input. And this is going to convert to, you know, arguably a, you know, fairly complex NURBS object, but it's actually very good quality. And because it's a NURBS object, because it's got, you know, high topological, you know, fidelity as far as like the quality of the surfaces itself, it's something that we can, you know, go in and edit and deal with. And I'm going to just let this run. It's finished up, and you can see that we end up with, you know, this fairly high density, you know, from an isoparametric point of view. It's very high density, but it is closed and it's good to go. And so I'm just going to turn off the surface isoparam so that you can see the result. And because it's high quality, if I bring this back, it actually booleans really pretty nicely. We can just take and do a Boolean subtract. I'm going to not delete my inputs. I'm going to bring my other side back. I'm going to Boolean subtract from this side. Now, I would have wanted to fix this little nub down here, right? Because that's ugly. You know, obviously there's some common sense stuff that we're going to have to extrapolate here from this process. But what ends up happening is, and I didn't delete my input, so it was in there as well, is I end up with a beautiful, and I got rid of the wrong side. That's the downside of not, I want to get rid of that one. You can see that we end up with a NURBS shelled part. And if I turn my edges off here, you can see the result. Now, the cool thing about this is totally refinable at the subd stage. Once you go from a quad remesh, once you go from Shrinkwrap to quad remesh to subd, once it's in subd, it's clay. You can mess with it and do whatever you want from subd. And so I would refine stuff like, you know, these little nubbins. I'd fix all that kind of stuff, and I'd clean all that up so that the core was good. But the process I wanted to show you, even if you work ugly, it works great. You know, it looks really good. And this is something that if I pick this thing, it's a closed poly surface. If I pick this one, it's a closed poly surface. These are both good. So I could punch this into SolidWorks. I could punch it into Pro-E. I could, you know, make an STL out of it and throw it to rapid prototyping if that was my jam. You know, but the process is valid. It works on very complex objects. There's a ton of flexibility. There's a ton of opportunity to edit and refine and get exactly what you want as far as the core is concerned. The question that always comes up is draft tools. There aren't any draft tools built into this process right now, so if that's something that's important for you, that would be something that you would probably need to address at the core, the sub-D core stage after you went shrink, quadri-mesh, sub-D. Once you're there, you'd want to run a draft analysis on it and identify any issues at that point and fix them there. Once you've done that, when you convert to NURBS, you do the Boolean subtract, and then you end up with this result, which you could take to whatever level of technicality that you wanted to take. Because these surfaces are very high quality, if you wanted to add ribs, screw bosses, battery boxes, anything like that, they would actually merge into this really nicely. And so you could take this part and develop it further and end up with a really comprehensive prototype part, depending on what you wanted to do. So that's what I wanted to show you about Shrinkwrap today. Hope you enjoy it. It's in the V8 work in progress, and that is available today if you are a V7 license holder. You can pick it up from the Rhino download page, which is rhino3d.com/download, and it's the Serengeti build right here. Give it a shot. Hope you enjoy. My name's Kyle Houchins, Techno Trainer for McNeil. Go make great stuff. Thanks.